All right, welcome to the video lesson on a perpendicular bisector of a given line segment. So a line is a perpendicular bisector. You can see right here by this diagram here, we know this is a perpendicular bisector because first of all, CD is perpendicular to AB, right? This line, CD, is perpendicular to AB, and how do we know that it's perpendicular? Because there is a right angle given to you right there. The next thing is that E is the midpoint of AB, right? And how do I know that E is the midpoint of AB? Because if E is the midpoint of AB, AE is congruent to EB, okay? And the distance from A to E is equal to the distance from E to B, okay? And that's given by these two marks right here. That shows you that what we've created here in this image is a perpendicular bisector, okay? So now what you're going to need to understand is we're going to need to calculate the slope in a coordinate plane, because you should know by now that perpendicular lines have opposite reciprocal slopes. So that's the first thing that we're kind of going to look at. And then we're going to make sure that in our segment that we find the midpoint. Now the midpoint is really just the average of the x's and the average of the y's. That's one way to really think about it. So let's go ahead and take a look at this problem right here. All right, I already laid out some things that you can kind of do right away, right? But it says, what is the equation of the perpendicular bisector that goes through this segment with endpoints A11 and B73? Okay, so right now we're looking for the perpendicular portion first, and then we're going to do the bisector portion next. Okay, so the first thing that I'm going to look at is, well, here are our graph points. So we're going to take a look at our graph points, and if I go ahead and then connect these right here, we need to find the slope of that line. We need to find the slope of that line, kind of try to determine what it's going to be. Okay, now graphically, we can look at the rise over the run, right? I can look at, well, how much does it rise? All right, the change in the y here is going to be equal to 2. So it rises up 2. And how far does it run to the next point? Well, I go 1, 2, 3, 4, 5, 6. So the change in the x's here is going to be a value of 6. Okay, so we know that. We know that just by looking at the graph. Okay, if we transfer this over here to a table, or we can see where we have points that I made, I laid out the points in a table. So what we can do here is determine, well, I know that 3 minus 1, the change in the y, is going to be 2. And then that 7 minus 1, the change in the x, is going to be 6. So that's how it looks like on a table. If we do simplify here, we find out that the slope of that line segment is going to be 1/3. Okay. So step 2, if I'm looking for a perpendicular line to that, I'm going to say, well, the slope of a perpendicular line is equal to the opposite, which means if it's positive, we need to make it negative. And then the reciprocal means we switch the numerator and the denominator. So now the 3 goes on the top, and then 1 goes on the bottom. Okay. Right now, I'm just going to leave it as -3 on top and then a 1 on the bottom, because it's going to help us graph a little bit. Okay. So the next thing is we need to find the midpoint. We need to find the midpoint. All right. So one tricky way to kind of find the midpoint, if I look at this graphically, we can kind of see where the midpoint is, right? And to check, if I drew two little triangles here, if I went up and then right, 1, 2, 3, okay, you can see, that if I go up and right, 1, 2, 3, and then do it again, up and right, 1, 2, 3, all right, that is the midpoint. Okay, so if you look at it graphically, you can find the midpoint by drawing two of the same triangles. Okay, sometimes it doesn't always work out nice and neat like that, but that's going to give us an idea to see if our calculations are correct. All right, so the midpoint here, right, should be the point 1, 2, 3, 4, comma 2. Well, let's go ahead and take a look at that algebraically, right? How are we going to calculate the midpoint? And really what the midpoint is we're averaging the x's and then averaging the y's, right? So if I take the x values, okay, you can see I've got 1 and 7, right? I'm going to find this. So 7 plus 1 divided by 2 is going to be the x value of the midpoint. And then the y value of the midpoint, if I've got 1 and 3, I've got 1 plus 3 and divided by 2. It's going to give us the exact midpoint. So if I simplify, I've got 8 divided by 2 is 4. And then I've got 4 divided by 2 is 2. So let's go over here and kind of check graphically and see if that's right. And there it is, right? This is the point 4 comma 2, which turns out to be exactly what we found out when we used our right triangles to determine the midpoint. All right, so now we know what this line looks like, right? Because if I have a point, now I can apply the slope. Okay, so the slope we said was -3/1, right? We've got the slope right here, -3/1. So I'm going to go ahead and graph it over here and see what that looks like. So if I know my slope rises 3, you can think of it as going down 3, right 1, right? Down 3, right 1. So I'm going to go down 1, 2, 3, right 1. Down 1, 2, 3, right 1. And there we go, right? Now I've got a line that is definitely 100% perpendicular, right? So I'm going to draw this line kind of through here, try to use a straight edge. It goes up and through. And there we have our line. And we know that this is perpendicular because these slopes are opposite reciprocal slopes. Okay? So now the last thing we need to do is, well, what is this equation of the line, right? And the point slope formula is really the most efficient way to use to find an equation for a line. And this is how it works, right? If we're looking for an equation of a line, we know we still have a y. And then I know I still have an x. I'm going to need those in my equation. Okay, so what do we know here? Well, we know that the slope that we're looking for is up here, right? So the slope that we're looking for is -3. Now this time I'm just going to write it as -3 because -3/1 is a little redundant. That leaves me with the other point. Like, what point am I looking for here? And in this case, we have the point 4 comma 2. So the x value is 4 and the y value is 2. So watch what I'm going to write. I'm going to write y minus 2 for the x value. I'm sorry, the y value, and then x minus 4 for the x value. And what's nice about this is you already have your equation. So if we have our equation right here, let's just distribute through. Okay, so I'm going to take this -3, take that slope, distribute it through. So I'm going to get -3x, and I'm going to get plus 12 because a negative and a negative make it positive when we're multiplying. And on the right-hand side, I'm still left with y minus 2. So the last thing I'd like to do is isolate my y completely. So now I can write it in y equals mx plus b format. Okay. So if I'm going to write y equals, now I've got the y totally by itself, and I've got -3x plus 14. So this is the equation of the line that creates a perpendicular bisector to the line AB. Now, what's unique about this, or one thing that you can kind of check on, is see how this is 14? All right, so this, if you graphed it correctly up here, if you have enough space, it will hit at 14 up there, if you did graph it correctly, okay? You can see my line kind of tails off a little bit. I don't really have a straight edge to use it, but when you're graphing on a piece of paper and you're graphing your notes, try to make sure that you use a ruler, because a ruler will make that line hit right up there, okay? There you go, one last slide of everything. So just a quick reminder, right? When we're looking for a perpendicular bisector, first, find the perpendicular aspect. Okay, that means find the slope. You can use a table like this. You can do y2 minus y1 over x2 minus x1. You can try rise over run on the graph, okay, which is what we kind of did to start. I think it's always good to kind of check both, right? You use the graph and a table and combine everything all together. Once we found the slope, okay, we found the opposite reciprocal slope, and then we found the midpoint. The midpoint is just the average of the x's and the average of the y's, right? Again, to kind of check that, we can just go up and over and up and over. And if we do it in the same amount, that means we're going to hit the midpoint right on, right? And the last thing to do is use the point slope formula with what we found. We know that this is the midpoint, and then we know that that is the slope. Okay? Hope this helps y'all. Good luck.